Okay. Right. Good morning, everyone. It's a real pleasure to be here. Thank you for the introduction. I'm Kyle Morris, a senior scientist and training coordinator at eBIC. That's the National Cryo-EM facility in the UK. It is a real pleasure to be here because I've never actually spoken about these things. It's all just been what we do. So it's been really nice to put this into a presentation. And I hope this will be yeah, a good contribution. So I start with some thanks as well. eBIC is a huge team, actually. When you look at it, we run four pretty, more than this, but at a base level, four pretty big cryo-EM instruments all year round, running overnight for all the experiments. And yeah, there's a very large team making that happen in a user facility context. And a special thanks actually with regard to what we're talking about in training. Actually, when I was writing this out, I was amazed at how many people have helped over the last 18 months. Lots of staff and postdocs and PhD students and senior team members giving their time to actually make this happen. So let me tell you a little bit more about what we do and what has been happening. This is my background, and this is cryo-EM. We are interested in taking pictures of molecules frozen in ice, and from these images, we can reconstruct what could be considered, at the very least, beautiful three-dimensional representations of biological molecules. So these are some that I've determined when I was a bit more deep into research exclusively, and within these models, what we're actually determining is seen in this mesh here. This is electron density, and inside that electron density, you can model what the atomic structure of these molecules are. And actually, this is quite low resolution now, but it's mine, so I'm proud of it. But we can get much higher resolution than this, and to the point where we can see atoms. And when you're getting to that level, then really you're talking about understanding chemistry of biology. So this is an electron microscope, something you've heard about already in the previous talk, which was excellent. A facility covering lots of different imaging techniques, but we exclusively run electron microscopes. Our samples are on a little grid right inside here, and the molecules are in ice, and we shine our electron beam through them, and there's a camera down here. The sample is actually on something a very small grid, the size of a matchstick head. So we might look at molecules in suspension, but we might also look at cells on that grid, and we burn away most of the material of that cell, leaving just a very thin section left, and then we can actually image inside the cell molecules inside that cell. So we really, our goal is to allow people to collect high resolution data for the sorts of projects I'm talking to you about. With a UK national facility for this, we run really the best cryo-EM instruments that are currently available, and we make those open to academic and industrial scientists. If you do some napkin calculations, we're running 4 Titan Cryoses, actually 5, 52 user sessions a month, about 20,000 images per session. We're collecting 1 million images per month on these microscopes. It's a really quite large operation. This is how they look, and I just bring this up quickly so you can see this whizzy 3-dimensional image. This is about to scale. This is kind of how it looks when you're standing in front of one. And there's our cryosol with 4 of them sitting next to one another. When we did this, they weren't even sure that you could put them next to each other that close, but turns out it works quite well. So our training and remote training really works because we already have a remote access model that is working. And that is that a user sends their samples from a remote location, from their home institute, and then there's a staff member on site who will load those samples. That staff member will also set up the microscope to be optimal for the experiment and Really, that is known because of a lot of communication that happens between us and the user. This sounds quite familiar to another facility you just heard about. And that planning allows us to set up the microscope perfectly for that user. However, then the user comes remotely and they are in charge and in control of their data collection. So we move from a sort of planning phase through to execution. And this is really important, we think, because users become invested in their data. However, staff will, same staff member will still be there to support the session. The staff member will be physically near the microscope. The user will be accessing remotely, and this piece of software, No Machine, allows the user full control. And then we use Zoom or Teams so that in real time, staff can talk to the user. And this closed loop, I think, actually makes this remote model pretty much the same as a user coming on site. After the session, the user can download their data, which has already had some analysis done on it automatically, and request their samples to be returned. Now, on to training, where we spend most of our time is training in this section, because yes, we hand over control to the user, but we want to make sure that when they execute their experiment, they can do that ideally as independently as possible. I believe that this is a good thing, but also efficiently and effectively. So we have 3 types of training, I think, how we can break this down. We have training that we run for the community, we have training that we run for our users, and training for our staff. On the height of these little sections is probably reflects the annual time we spend on that activity, and the length of the sort of left to right is really the size of the audience that we deliver that training to. So to users, our methods are demonstration by an expert and then handing over control for practice, and we really do a lot of repetition. It sounds boring, but actually, well, I'll come back to say why it's not boring. And the purpose of that is for efficiency and effectiveness, and what that looks like is a user training program, which I'm going to talk to you more about in the next slide, documentation and guides, again, familiar themes, and really trying to make all of this very accessible on our website. I think these things are the backbone, actually, of our training. To the community, we do something a bit different. We sort of step back and we have lectures, and we still run practicals, but we make these more about demonstration rather than giving control and allowing practice. We consider this to add value to the community. It's a place where we can generate resources, and it's also a place where we can generate and test out training methods. So that looks like this, a bunch of open access workshops that we run throughout the year. And then, of course, underpinning all of that are the staff and the instructors. It's sort of strange, actually, that we spend the least time training this, but I think it's because when people come to eBIC, they generally know a lot about cryo-EM already. But of course, we run staff training. It's often very specialized, very specific to the needs of that staff member, and thus ad hoc. And this is for best practice and consistency internally. So that's on-the-job training for running sessions and delivering remote training. I'll talk to you about these 2 parts of the pyramid. I don't have time to talk to you about staff training. So looking at the users, remote user training. This actually started in the pandemic. Very similarly, we were forced into this remote model, but it's gone quite well. And to complement us running in that mode, of course, now we deliver quite a lot of our training remotely. So here's a picture of me in the middle of this. I'm sure many of you will relate to this. It's ironic that even when you're online, you still point to the screen that you're trying to talk about. So there's still room for learning. And I'm really quite proud of this. The model reflects how people access the microscopes anyway, but in our training, there'll be a person at a monitor that is talking to the instrument. I think we're very lucky that we have software that controls our instruments. And then up 4 to 6 people coming in remotely. They can talk to us on site via Zoom, and they can each individually control the microscope at the same time, actually. So there's a little bit of coordination required there to make sure everyone plays fair. But, you know, effectively the people coming, every single person has the microscope right in front of them, and they can control it via the software name machine. We have a very, very well settled program now. The first day is demonstration, what we would consider gold standard operation. This is people just watching over Zoom, so it's much like a workshop. But then we systematically hand over control on the subsequent days to pairs of students. So they get to repeat what they've seen, but they also get to watch their colleagues repeating what they've seen. And we find that this allows us to actually get quite a reinforced level of learning very quickly over 3 days. So we started off running these pretty frequently, instructor 1:4 ratio, 1 microscope. Now we're running them less frequently because there's quite a lot of fatigue around doing this kind of training, it turns out. But we're scaling those up to run more microscopes and bring in more people. And I hope over the next year I'll be able to report that just increases. And it's really nice to report that actually prior to the course and then after the demonstration and then after their practice, we go from a range of confidence levels through to everybody at least being somewhat very confident in setting up their experiments. Underpinning the sort of the instructor to student one-to-one training almost, we really try very hard to put a lot of materials on our website. These do form the basis of a curriculum for our training, but further to that, they can also be accessed when a user just comes for their normal session, and they can follow these guides for setting up. And here in the background, you see someone selecting some holes on a cryo-EM grid, going from not having many targets to selecting a bunch of great targets and excluding some bad ones. But let's not dig into cryo-EM too much. So then the other thing that I said I was going to talk to you about that I wanted to tell you is where we sort of step back and we look more at training the community. And I just have a couple of slides on this. We're interested in training the community because we want to bring more people in to use this technique. There's a real need for it. It's still surprisingly specialized, but we want to try to open this to more people. We make these courses free and we try to make them as accessible as possible. So community training looks like morning lectures and afternoon practicals. We make these virtual, but actually our most recent course was fully hybrid. We bring in larger audiences. For the lectures, actually this has been several hundred people for one of these courses. And then for the afternoon practicals, we're still at the point where we have to restrict the numbers of people. We've handled up to 20 people in these practicals. There's no way we could do the really concentrated sort of personal training for that number of people. We don't have enough staff, we don't have enough instruments, but that's okay. As I've said, I think the point here is that we want to reach a larger audience, and the way we do that is we make these more demonstrations and still interactive and people asking questions. So we run this in a variety of workshops over the year, and this is part of a much larger national effort funded by the Wellcome Trust and MRC to deliver this kind of training. So you have 30 seconds, so I'm going to get a bit whizzy. I said that we use the community training as a way to test technology, and this is something that we're really excited about, this technology, and I think where I want to leave a thought, that actually we now have these cameras, these Logitech cameras. I don't work for Logitech, but these are really great. We can focus them on an instructor doing something in the lab, and we can broadcast that to another room, or we can broadcast it to Zoom. And the point there is that if you have an instrument, particularly something that is hands-on, where it's very difficult to get lots of people around this instrument, we can broadcast it to a room where multiple other people can watch, and then we can swap those people around. So everybody gets hands-on time, but everybody gets to see at the same time. And what we're thinking about now is actually scaling up demonstration of something which would typically be one-on-one training to a very large virtual audience. And we think this is really, really interesting. So eBIC is part of a very large campus. It's at the Diamond Light Source of synchrotron. There are lots of different technologies that you can access on this campus. We are free at the point of access. We cover travel, sample shipping, accommodation if you're coming on site, and your food. And if you're in Europe, there are lots of additional ways that you can get money to access our facilities. So in the interest of time, I won't summarize too much. I think just to say we can reach more people in a high quality way, with a low barrier to attendance. It's easy to scale, and the streaming technologies are becoming really interesting. And that's why we're really enjoying our remote training platform. So thanks to the team again.